Okay, we'll go over the chapter 3 review. There are some terms here, protons, neutrons, and electrons. So let me remind you that an atom is made of 3 subatomic particles, the protons, the neutrons, and the electrons. Protons and neutrons are found in the nucleus of the atom, and then the electrons are in the electron cloud, so roaming around the nucleus. And the electron cloud is what gives the atom its size, right? Because the nucleus is really a tiny, tiny, tiny dot in the middle of a sphere, right? You really have to visualize that the atom is mostly empty space. And so electrons are negatively charged, protons are positively charged, and neutrons have no charge. So neutrons refers to neutral, right? They are neutral. Or neutral, if I say that properly, sorry. The mass of the atom comes from the protons and neutrons. They each, a proton has about 1 atomic mass unit, each proton, and each neutron also is 1 atomic mass unit. The electrons do not contribute to the mass of the atom, right? Electrons have a, are 1 atomic mass unit divided by 1,000, so their atomic mass unit is negligible compared to the mass of a proton or the mass of a neutron. So in conclusion, protons and neutrons are giving the mass to the atom. They are located in the nucleus. And then electron cloud gives the size to the atom. And electrons and protons are giving the charge, the electrical charge to the atoms. And when it's charged, we call that ions, right? They become ions. So let's go over this first practice problem. Identify each atom or ion. And so please respond by chat. Unless you have no background noise, then you can unmute and reply, answer by saying the word or the answer. But otherwise, you can use the chat to answer. So, okay, we have this atom or ion that has 37 protons, 48 neutrons, and 36 electrons. So I want you to identify that atom or ion. So type that on the chat or tell me. Yeah, it's an ion. So we know it's an ion because we have 37 protons and 36 electrons only. So I want you to identify precisely, tell me the symbol of, look on the periodic table and find it, right? Because remember how the number of protons is the identity for your atoms. You can identify an atom from its number of protons, because the symbol is related to a number. They go hand in hand. When you have 1, you can find the other in the periodic table. So here we have 37 protons, and yes, most people got it right. It's rubidium. So let me put this here. And rubidium has for symbol Rb. And so we said it's an ion, it's charged. What is the charge on rubidium? So just tell me a plus, 2 plus, or minus, 2 minus. So we have, so from the information we have 37 protons, which means 37 pluses, and 36 negative charges. So 36 negative charges will cancel 36 protons, yes. And 1 of the proton will not be cancelled. So it's positive 1, not negative 1, right? You have to be careful here. And so please watch how I do the superscript. When you are on Word, hopefully you will have this accessible to you. You want to use the superscript, the X looks like Control, Shift, and plus together will make it superscript also. It's important that you know how to do this if you do your lab reports and you know, on Word. I want you to write the ion symbol properly, and the subscript and superscript, I want you to format them properly. Okay, so I expect you to, if you do it on Word, not by hand on paper, then you need to know how to do the superscript and subscript. And so here it's given in the font, you know, in the font editing tool. You have the X2 and X squared, if you will. And so use those. Okay, so rubidium. And so how do we know that rubidium is +1? Just by looking at the periodic table, rubidium is group 1A. It's an alkali metal, and the group number tells you the charge. Another thing is rubidium is a metal on the left side of the periodic table. So it's to be positive when it's an ion. All metals become positive ions. And group 1A tells you it's +1. Okay, let's do the next one. 79 protons, 118 neutrons, and 76 electrons. What is that? So tell me the symbol. And if you're not ready for the charge yet, just give me the symbol for now. And if you know the charge, give the charge. So again, the number of proton is the identity. You can find your symbol by looking at atomic number 79, right? Atomic number is the number above the symbol. And yes, and it's gold. And gold has a symbol that is not intuitive. It's AU. It comes from aurum, the Latin of gold, the Latin word for gold. And so, yes, we have 79 protons minus 76 electrons. It's a difference of 3. And because we have more protons than electrons, it's going to be positive. Sorry. Okay, I have to do them one at a time. Oops. So AU3+ is the answer for this one. What species fits each description? So let's do number A. A period 3 element that forms an ion with a -1 charge. So remember how periods in the periodic table means row, right? So period 3, and it's an ion that forms a -1 charge. Yes, and I just told you metals do positive ions, right? They become cations. So it's not going to be a metal. So you have to go to look into the non-metal side on the right side of the periodic table. And so for non-metals, you know the charge of the ion they become by doing 8 minus the group number. So here, 8 minus the group number has to be 7. I have not given it. Oh, you want the file already? Hold on. Continue. So we were saying that non-metals do become negative ions. And so to get one negative charge, it means the ion has to come from group 7A, because you do 8 minus 7, it's 1. And -1 because non-metals make negative ions. And period 3 means chlorine. If you look at the third row, it's chlorine, and it's going to be -1 there. The negative sign is a bit tiny, and when it's in superscript, it's really hard to see, but it's there. Sometimes I use something different. Let me pull that. Yes, that's more visible this way. Okay. Okay, let's do B, an ion from group 2A with 36 electrons. So group 2A, remember how groups are columns. So you look at the column 2A, it's called alkaline earth metals. Alkaline earth metal with 36 electrons. So, yes. So the way to find this, 36 electrons, you want to find the alkaline earth metal that is closer to that number in number of electrons. And if you look, 36 is the krypton noble gas. And what comes after that is strontium from group 2A, has 38 electrons, but it will lose electrons to have 36, right? So it's strontium, because it's from group 2A with a number of electrons close to 36. But then it has a 2+ charge, yes, because from 38, strontium needs to lose 2 electrons to have 36. Okay, good. An ion from group 6A with 18 electrons. So 6A doesn't have a particular name for the group, right? That's where you have oxygen, sulfur, selenium, tellurium, polonium. So 18 electrons. Yes, you want to, 18 electrons corresponds to argon. So you want to be close to that, and the closest would be sulfur. So sulfur, S. And sulfur, when it has 18 electrons, it means it had gained 2 electrons, going from 16, atomic number 16, so 16 electrons, plus 2, that's 18. And those 2 electrons will give a negative charge to sulfur because they are not cancelled by protons, so they will show up as a negative charge on sulfur. Okay, so that's the answer for this one. Okay, so let's name this S-2. What is the name of that ion? Can you type it? So the nonmetals, when they become ions, sorry, I have problems with my formatting here. So this is called the sulfide ion, right? Nonmetal, when they become ion, we change the ending to "ide." So that's the sulfide. For metals, the name of the strontium atom here. Okay. It's just the name of the metal, right? So it's going to be strontium. It's the strontium ion. And what about the Cl-? Can you give me the name of this one? So nonmetals, when they become ions, we change the ending to "ide." So chlorine becomes the chloride ion, right? Chloride ion. Okay, so it's just to, yeah, we'll go over the naming later on. So let's do table 3. Complete the following table for these elements, which are essential to health. So complete the table when they become ions. We have magnesium, oxygen, potassium, iodine, zinc. So first, I want you to determine if they are metals or non-metals. Then I want you to give the group number where we find them in the periodic table. Next, you need to tell me when they become ions, do they lose or gain electrons? When they become ions, how many electrons do they lose or gain? And then give the symbol of the ion formed. Okay, so let's start with magnesium. Can you tell me first if it's a metal or a non-metal? Magnesium. Metal, yes, that's a metal. It's in group 2A. It's an alkaline earth metal. Yeah, so we just said group 2A. So, you know, depending on the periodic table that you use, they may have just the numbers that go from 1 to 18, you know, columns. I want you to use the group numbers that have the A and the B. This is really helpful. I'm sure you've seen that now, that it's very helpful to know which ones are the A groups and the B groups. And the group number is really telling you information about the elements in that group. So, okay, so magnesium, when it becomes an ion, does it lose or gain electrons? Knowing that it's a metal. Yes, it's losing electrons. Lose. Yeah, lose or no, lose like that. Okay, it will lose electron because metals become positive ions and they need to lose electron to have an excess of proton and be positively charged. So they will lose. How many does magnesium lose? Yeah, lose 2 because it's in group 2A, and that tells you it has 2 valence electrons and it wants to lose them to be like a neon, because atomic number is 12 for magnesium. When you lose 2 electrons, then it goes from 12 electrons to 10 electrons and be like a neon. Okay, so it's magnesium 2+, right? And so you have to be very careful to show this as a superscript, right? If you do your work on Word, you need to be able to do this superscript or subscript. Otherwise, I will not like that if you don't do this. So oxygen. So metal or non-metal? Yes, non-metal. What group? 6A. Yes. Does it gain or lose electrons when it becomes an ion? Yes. Oxygen will gain electron when it becomes an ion. And it will gain how many? Yes, it will gain 2 to be like the next noble gas, like neon again. Because oxygen, atomic number 8, has 8 electrons in total. And it will gain 2 to be like neon and have 10 electrons, you know, in total. So the symbol is O, -2, right? We said when you gain an electron, those electrons, they become they are not cancelled, yes, and they show up as negative charges, right? When you have an excess of electron, because oxygen here has 10 electrons, but 8 protons. 8 protons will cancel 8 electrons, and you will have 2 electrons in excess. And those electrons are negatively charged, so they show up as a negative charge. Okay, potassium is a metal or a non-metal? Potassium? Ah, what's this? Yes, what's the symbol for potassium? Oh, potassium. Potassium is a metal, symbol K, right? I hope everybody has a periodic table. Hopefully those who were supposed to receive packets, they got them. It really is out of time for that. Yeah, it's fine. Okay, so it's a metal from group 1A, alkali metal. It's an alkali metal. You know, those very reactive metals. Okay, will it gain or lose electron when it makes an ion? So potassium. Yes, it's losing electrons. And how many? One. Losing 1 electron. So K plus, right? Plus as a superscript. That's how we indicate the charge for the ions. They have to be in superscript, so in the upper right corner of the symbol. Okay, so potassium, and we know that potassium being a metal will become a positive ion, and being in group 1A will be a +1 ion. So iodine, is it a non-metal or metal? Yes, non-metal. It's a non-metal. It's on the right side of the staircase line. It's in group, yeah, 7A. Okay, so as a non-metal, does it gain or lose electrons to become an ion? Yes, it gains. Gain electrons, because it's a non-metal, it will gain electron and become a negative ion. It will gain just 1, right? Gain 1 electron, because iodine, being from group 7A, has 7 valence electrons. You remember how the group number for the A group is equal to the number of valence electrons. So iodine, group 7A, has 7 valence electrons. It wants an octet, like all atoms, most atoms, except helium and hydrogen. So it wants 8, because an octet means 8 valence electrons. So by gaining 1 more electron, it will have 8 electrons around it. And so it becomes the I minus ion. Let me change that to a more visible. That's a big line. Okay, I minus, it has to be visible. Let me change that one too. Okay, so tell me, what is zinc, a metal or a non-metal? Zinc. Zinc. Yes, zinc is a metal. So what is the group of the group number for zinc? Yes, 2B. So here we have a B group. So those B metals are called transition metals, or the B groups, and they are not main group elements, right? They are not. So it's a metal. Does it gain or lose electrons? Oh, yeah, I didn't realize that this is okay. You can answer that. It's a metal, so it will lose electrons, yes, but you may not know how many though. Okay, zinc as a transition metal should be a variable charge metal, which means a metal that can make different kinds of cations. Like, for example, copper next to it can be Cu plus or Cu2 plus. Zinc is an exception with silver. Both of them are making only one kind of ion. And zinc is making a 2 plus ion. So if I tell you it's a 2 plus, then you should tell me how many electrons it loses. It's losing 2, right? And that was not something, yeah, it's not one of those predictable ions because it's not in a main group element. But zinc and silver are exceptions, and it would be a good thing to remember. It's always 2 plus. So it loses 2 electrons. Okay, so but all the other ions are predictable ions, and you can find the type of ion they become by looking at their position in the periodic table. It is important. It is important to know how to do this. You know. Okay, thanks God. I'm sorry that you have to leave. Maybe I'll ask if we continue or stop here and do the rest on Wednesday. Hold on. Okay, practice problem 4. Write the formula for the ionic compound formed from each of the following pairs of ions. So now that we know how to find the formulas for or the symbols for the ions, we will learn to combine them and make ionic compounds, right? Ionic compounds are made of ions, positive ions and negative ions, that are attracted to each other because they are oppositely charged, right? And so it's a strong electrostatic electrical attraction that, you know, puts them together. So let's say you have an aluminium ion and an oxide ion. So the first step would be to find their symbol, and then we'll do what we call the crisscross trick to find the formula. So first, what is the aluminum ion? So the reason why I you know, don't give the symbol, it's because it's those predictable ions. From the position in the periodic table, you are able to tell me what kind of ions they are. So aluminum, the symbol is Al. So find it in the periodic table and then tell me what is the charge on aluminum. Yeah, So aluminum is 3+ because it's a metal from group 3A, right? It's under the staircase, so it's a metal. Even though it's touching the staircase here, it's not a metalloid, it's a metal. And metals of group 3A are predictable ions. They form 3+ ions. And so we have that. And give me the oxide ion formula. So oxide, in there you see the beginning of oxygen, right? Yes, so it's oxygen. And oxygen being in group 6A, so you do 8 minus 6 is 2. And it's a -2 because it's a non-metal. So they form negative ions. Okay, so we have the formulas of our ions. When you are making an ionic compound, you always write the positive ion first and the negative ion second. So, and then the crisscross tricks tells you that you can take the charge of the aluminum and make it a subscript for the oxygen. So, and the charge of the oxygen, just the number, not the sign, the 2 from the oxygen will become a subscript for aluminum. Sorry that I cannot show that more clearly, but so the 2 from the charge of the oxygen becomes a subscript for aluminum. So we write it as a subscript. Yes. And then let me write the 3 here on the O. Okay. So be careful. These are subscript now. They started as charges, but now they have been exchanged and become subscript. And you completely drop the plus and the minus signs. They should not be showing up anymore when you have the formula of a compound. Because to find the formula of a compound, you want neutrality. You want it to be neutral, as many positive charges as you have negative charges. And so they cancel out. And so you shouldn't show any more positive or negative charges. And now we have subscript to tell how many of aluminum we have. Here we have 2 aluminiums for 3 oxygens. And you can see that 2 aluminiums times 3 plus each aluminium, that's 6 positive charges. And 3 oxygens with 2 negative charges each, it's 3 times 2, it's also 6, but negative charges. And so 6 positive charges cancel the 6 negative charges. Okay, so let's do magnesium and chloride ions together. Again, I don't give you the symbols because you are supposed to know what kind of ions they are from their position in the periodic table. So magnesium, Mg, what is the charge on magnesium? Yes. Okay, it's magnesium 2+ because magnesium is in, yes, sorry. And, okay, can you give me the symbol for the chloride ion first? So it's Cl, but what is the charge? No? Yes. Okay, chlorine is in group 7A. 7 minus 8 or 8 minus 7 doesn't really matter, but it's only 1 difference. And so it will show up as 1 negative charge on the chlorine. Okay. And so when you do the crisscross trick, indeed, you get Mg. And so there's a subscript of 1 coming from the -1 charge of chlorine. And when you have a subscript of 1, it's implied, you don't write it. So you continue with in. And the 2 from the 2+ of magnesium will become a subscript for chlorine. And so the 2 here appears as a subscript now, right? So MgCl2 is the formula for the compound made of magnesium ion and chloride ions. And so here we didn't have to change the crisscross trick gave us the final formula right away, right? We didn't need to simplify. But you have to remember that sometimes if you have a ratio of 2 to 4, it can be simplified to a ratio of 1 to 2. Okay, so be aware of that when you're using the crisscross trick. Okay, let's continue with writing the symbols of the ions given the name of a compound. So you have this name and you want to retrieve the ions that are forming this compound and find the formula. So maybe it's going to be easier for you to first find the formula of the compound and then retrieve the ions after that, or either way, right? Or you find the cations and anions symbol given the name and then write the formula from there. I'm not sure. Both ways are good, but let's do the cations and anions in the case of barium sulfide, because that's going to be, it should be easy because the name is just the name of the cation and then the name of the anion. So the names are really the names of the cation and the anion put together for the name of the compound. So what is the barium ion? So tell me the symbol for barium. Yes. Barium is a symbol Ba and it's in group 2A. It's a metal from group 2A. So it's going to be a positive ion and it's going to be a 2+ ion. Okay. So now tell me the symbol for the sulfide ion. Yes. Let me change that. Okay, and so, oops, put together. What is the formula of the compound? So, yes, very good. You can see right away here that you don't even need to do the crisscross trick, because you see that barium has 2 positive charges, sulfur has 2 negative charges. They will cancel out and you need 1 of each. If you had done the crisscross trick, you would have had Ba2, S2, right? And you see that those two twos, they can be removed and then it becomes BaS, right? A ratio of 2 barium for 2 sulfur means 1 barium and 1 sulfur are making the formula neutral. Okay, iron 2 hydroxide. So when you have a Roman numeral in parentheses, this indicates a transition metal, which means a metal that can form different kinds of ions. And the Roman numeral tells you the charge of the iron in this particular compound. So in this compound, we have iron 2. And the 2 here refers to the 2+ of iron, right? Iron is Fe, the symbol Fe. And iron 2 tells you that it's iron 2+ in this formula. The hydroxide. And so for this, you need the reference tables, you know, the reference for unit 1. let me show it briefly. Okay, so if you look at your reference information for Chem 121 for Unit 1, you have these two tables of metric prefixes and equalities. And then you have this list of names and formulas of common polyatomic ions. It is important to have this under your eyes when you do chapter 3, because whenever you encounter some of these formulas in compound formulas, or if you see the name, you need to refer to that table. I don't expect you to learn this by heart, so have this available whenever you use a do chapter 3. Okay, so it's page well, there's no page number, page 3 of the reference for Unit 1. Okay. So from the reference, we saw that the hydroxide ion is OH minus. I didn't really took the time to show that, but if you look there carefully, you will see that hydroxide is OH minus. I want you to be aware that it ends like oxide, and you would think, oh, maybe it's a non-metal made of just one type of atom, like oxygen gives the oxide ion, but there is hydro in front, so it's a hint that there is actually more than just one type of atom. And here it's hydrogen and oxygen together with one negative charge. So okay, formula of the compound. So you write the Fe and then OH. The negative one for the negative charge of the hydroxide will become a subscript for iron, but it's a 1, so we don't need to write it. And then the 2 from the charge of iron will become a subscript for the hydroxide. Because it's more than one hydroxide, we will need parentheses around the hydroxide. And you will do it like this and give the 2 there. And the 2 here belongs to the parentheses. It's for what's inside the parentheses. And so it says you have 2 OH minus per Fe2 plus. That's what it says. And that's what you need to have a neutral formula, right? You need 2 hydroxide ions. So that will be 2 negative charges to cancel the 2 positive charges from the iron. Okay. So when you have only one of the polyatomic ion, you don't need parentheses. You only need parentheses if it's more than one polyatomic ion. Okay, ammonium sulfate. And here you really need to go to that table. Hold on. So we have ammonium sulfate. Ammonium, find ammonium here. Ammonium is a polyatomic ion made of nitrogen, and it's NH4 plus. So we will have NH4 plus as the cation. And sulfate. Sulfate here is in a bold. It's a polyatomic ion made of sulfur, and it's SO4 negative 2. Okay, SO4 negative 2. So then you go back to your so it's NH4 plus. So the 4 is a subscript, the plus is a superscript. Be careful, they are not the same thing at all. The 4 means you have 4 hydrogens for 1 nitrogen, and the plus is for the whole, ion together. SO4 negative 2. Here it's the same. Let me change that. So the 4 is a subscript that belongs to the oxygen. It's 4 oxygen surrounding sulfur. And then the 2 negative charges are for the ion, the sulfate ion. So it's really two different things, very separate. You have really do not be confused by these. You know, the subscript tells you how many atoms you have of, you know, the atom that is just to the left of the subscript. And the charge is in the upper right corner, and the charge applies to the whole polyatomic ion. So when you do the crisscross trick here, you see that you will need the 2 from the sulfate charge will become a subscript for the ammonium. So we have ammonium, it's NH4, and the 4 stays there. It's just the plus that will be gone, right? The charge, and it's the 1 from the ammonium will be a subscript for the sulfate. So let me write these two together. SO4. Okay, so the +1 from the ammonium will tell you that there is only one sulfate. So we don't need parentheses around the sulfate, there is only one. And the 2 from the 2 negative charges of sulfate will become a subscript for the ammonium. So here we will need parentheses around the ammonium because we need 2 of them. And the parentheses should be normal size. And then the 2 here is a subscript, right? So here it says you have 2 ammonium ions for 1 sulfate. And so the negative and positive charge disappear, and the 2 negative charges from the sulfate have become now a subscript for the ammonium, right? And so ammonium needs parentheses because there is 2 of them, but sulfate doesn't need parentheses. I hope you're still following me here. And you can see here that with 2 ammoniums, yes, 2 ammoniums, you will have 2 positive charges. They will cancel the 2 negative charges from the sulfate. So this is neutral. Okay, let's do lead 2 bromide. The symbol for lead is Pb. And Pb is a, it's not a transition metal. It's not in those B groups. It's actually in group 4A. But group 4A is not it's not making predictable ions. Only group 1A, 2A, and 3A for metals are predictables, right? So Pb in group 4A is variable charge metal, even though it's not a transition metal, it's a variable charge metal. Typically it makes a 2+ or 4+ ions. And here, because the Roman numeral says 2, that means in this compound it's going to be a 2+. 2+. Okay, the bromide. Bromide comes from bromine. Symbol is Br. It's in group 7A. It's an halogen. 7A, so 7 minus 8, it's -1. It's going to be a -1 ion. So notice how instead of saying 8 minus 7 is 1, I said 7 minus 8 is -1. You can also do it this way and you see right away that it's a negative ion. But you should know that non-metals make negative ions, right? They don't make positive ions. Okay, so put together, always write the positive ion first and then the negative ion. So the 2 from the 2+ of lead will become a subscript for Br. So let's write a 2 there. And that's going to be a subscript. You know, it became, you know, from a superscript, now it's a subscript for Br. And the 1 from the negative charge of bromine becomes a 1 subscript for Pb, which means we don't write anything. We leave it like this. It's implied when it's a 1. So the formula is PbBr2. And you can check that when you have 2 bromide ions, that's going to be 2 negative charges in total, and they will cancel the 2 positive charges from lead. So that's the correct formula. Okay, silver oxide. So silver is a transition metal. It's in group 1b. So it's in a B group. We call them transition metals. However, I said earlier that zinc and silver are exceptions. They make only one kind of ion. So they are predictable. It's more like you need to learn because you cannot know from the position in the periodic table what kind of ion they become. Silver is always, silver is always a +1 ion. Okay. This would have to be given to you, or you in your notes put that down, that silver is an exception. It's always Ag+. And oxide comes from oxygen. Oxygen, group 6a, 6 minus 8 makes a -2 ion. It's a non-metal. Non-metals make negative ions. Okay, now let's put them together. So I will rewrite their symbols. Okay, so the 2 from the oxygen -2 charge will become a subscript for Ag. So let's make it a subscript for Ag. And the 1 from the Ag plus will become a subscript for oxygen, which means we don't write it and it stays like this. So this is the formula for silver oxide. Let's make sure we have 1 oxygen with 2 negative charges and 2 silvers with 1 positive charge each. So that's going to cancel out 2 plus 2 minus. This is a neutral formula.